these are just some facts, and they might cause a lot of questions, but this is why exactly why I want to outline them, so we could have a good Q&A session around it. So, important thing you should know about TON is that the contracts are working as an actor model. So, actor model means that each contract can either send or receive messages. So it can, when it receives the message, it can change its state, and when it is sending the message, it is supposed to change state of another contract where it's sending it. So it's not, you cannot call a contract, you cannot call a get method of another contract inside of the contract code. So you basically, your contract is working in a way that it sends the message and it doesn't care what is going on later. So anything that comes out of the contract doesn't care what is going to, if the message actually will end up in the proper contract or not. So this is like something that you would need to consider when you understand the logic, especially if you come from the Ethereum background. Virtual machine. Virtual machine is it's called TVM, TON virtual machine. It's actually used for executing contracts. So your contract is getting into the memory of TON virtual machine. It is executing the code. The state of data is changing inside of the contract, and the result of it is recorded on the blockchain, and validator is actually confirming this change that happened. We're going to talk about memory later on. External messaging. It is a very cool thing that in TON you have two types of messages. We're going to talk about this a bit later, but external message means that you could trigger a contract from outside of the world by, it's not even by wallet. It's like, because we know wallet is a contract as well. So you could simply trigger a contract from outside of the world. And this contributes to the interoperability we were talking about on the previous session, that the contracts can be interacted with from outside of the world. And for this, we use external messaging. Fancy. the funnest part is, as I said, the biggest lie about fancy is the word fun. But I truly believe that when we will get more, 1, 2, 3, yeah. When we will get more high-level languages, we will have a lot of fun remembering about fancy. This is for sure. So basically, it is like statically typed. It's very in the syntax, as far as I know, it's very similar to C language. And what is important is this standard library. So there is one main library that is actually holding a lot of functionalities, a lot of features that are somehow connected with assembler. So these functionalities are actually giving us logic that we don't have to re-implement. It already has the implemented assembly commands, so we just use this library. So don't be surprised that in every of your fancy project, you would have to have this library included, because you're going to use a lot of functions that are actually already implemented inside of this library. Fully universal. This is a fun one, because the contract. So in TON we call contracts accounts sometimes, because, and this is one of the reasons, because contract is like an entity. It can hold money, balance. It is storing code, the actual code that it executes all the time. It is storing data, the current state of contract. And the cool thing is that you could even like rewrite the code of contract, not rewrite, but change it. So the code is not immutable. So there is a magic function called set code, and you could under certain circumstances, so you could either send a code that you want to set in there, or you could just hard code that if, like before this date, before this block or epoch, there's this code, and then it changes to something else, you know? So Fancy is very, very flexible, and we are given this flexible tool, and it might be that this is why it's not so fun, because we have to figure out so many things, and this is just different level of abstraction, you know? You have to go quite abstract. You need to understand so many concepts in order to take the best out of Fancy. But this is also cool because then you can basically adjust it to whatever you need. And currencies. So basically, this is the work chains that I was talking about. So we could basically run a whole different currency, native currency like a ton, but another currency that wouldn't be a token. It would be a complete other layer one, let's say, on the same layer. So it wouldn't be, I think it's not considered layer two, but anyways, Ton out of the box is supporting crazy amount of native extra currencies, namely the amount of work chains that we have is like 2 in the 32nd degree. Okay, so these were like a blitz. We quickly run over a number of techie facts. Who has no idea what is going on? who was like who didn't, for whom it did make sense? Raise your hand. Okay, which part of it?
So the actual model, like so you mentioned, so we have.
Well, just 1 second. I think we should find the second microphone if it's possible. This would be very, very cool. Because I think it's worth running the whole Q&A session for like 10-15 minutes just around this fact.
Yeah.
I understand that it might be complicated to just, we can't just go continue to the next topic. Let's first handle this part. Oh, there's a mic. There's a mic. Woo! Nice.
So in the active model that you have mentioned, like suppose if we have 2 contracts, so we have the 2 contracts like a second contract, so we don't get any acknowledgement from the second contract, right?
If I got you right, so one contract doesn't know about second contract, or yes, basically, yeah, basically yes, because your contract in Fancy, it only does 2 things. It is sending messages with a certain data structure, and it is handling messages. So it's not like it talks with someone. It's like a robot. It is able to handle like 10 types of messages. Let's say, I will talk more about this, like what I mean by types of messages.
Okay, so like I will give you the scenario here. Like so, suppose I wanted to build an applications, so which is related to DeFi. Like consider like so I have 2 contracts. One is related to the derivatives market, so where we post our prices and all the other things. One more, I have a X related contract which is related to the spot contract.
Yeah.
Suppose if I wanted to get a prices in the spot contract from the derivative contract.
Okay. That's a good question. How I would do it, it would be, I would use Oracle to write it directly into DEX contract.
So, I mean, those are in the same network, right? I mean, the so TON network only, but if you use a Oracle, so yeah.
So, sorry, I might be not understanding.
I mean, the question is like, so we have 2 contracts right now. So one is a spot contract, one more is a derivative contract. So suppose.
So one is smart contract?
Spot contract.
Smart contract.
Spot is like, suppose we just wanted to know about the particular token's price. So
Okay.
we listed in the DEX. Consider
Okay.
like we listed in the DEX, one atom or something, any other token, BTC. So I just wanted to access this price of this price in the spot based on the derivatives contract.
Ah, okay. I understand what you mean. There's no derivatives on tons. Yeah.
I mean,
consider
like an example.
I'm just saying because
Consider like an
if
example.
someone says derivatives, it means that you actually work with them, and it's a good niche for you. If you know what it is and how to build it, jump there because there is no still. So let me quickly. The question is, there's 2 contracts, and you are. So in one contract, you have to do some action, but your action should be based on the data that is stored in another contract, right? This is a fair question. So if we remove the derivatives and stuff from it, so this is what it is. So you have one contract. This contract wants to send Mark some money, which is cool. And basically this contract has to ask another contract how much money he can send to Mark, right? So it would be implemented in the following way. You would have to, in your contract that is supposed to send money to Mark, you would have to handle a message that would say, send this amount of money to this address. And then, this will be the, I would, is there any whiteboard? No, we don't have, right?
I think there's a whiteboard.
Do we have
behind-
whiteboard? Nice.
That's a whiteboard behind that.
Oh, it's too far. Because with a whiteboard, I could actually explain you how I would do it, and this maybe this very very useful.
They're getting it, Mark.
Huh?
They're getting it.
Yeah, they will get it. Okay.
They're getting it. You can
Yeah.
carry on. And
Yeah, so basically, you would have to handle the trigger message. So trigger means like the contract A, the one that is supposed to send me money. You would trigger it and say, send Mark some money. So this would be the first message that you have to handle. So when you handle this kind of message, you are sending another message to contract B. And this message means like, you're sending the address and you say, how much money can I send to this guy? And then this other contract, he would get the address of my wallet. It would check on the token price or whatever, on the balance, it would check how much money you can send me. And then this contract would send another message to contract A, and this message would say, send this amount of money to this address. So it would be like just executive message, you know? So basically, it cannot be made in one transaction. It would have to be basically 3 transactions. So I hope this answers your question, but with a whiteboard I would explain it much better, but does it make sense? Does it make sense?
Yeah, it makes sense, but it's like a loop kind of thing that you're mentioning, right?
Sorry?
So like if I send a transaction from smart contract A, so then I need to go to smart contract B, then again I need to go to smart contract 1, right?
Yeah. So basically, your smart contract A would have to handle 2 kind of messages to send you money, and this is not a problem. The amount of transactions is not a problem because. Yeah? We can put it here maybe. Yeah. We can put it here so it wouldn't. I wouldn't kind of close it. Thank you very much, guys. For the study. So I was saying that it's not a problem because we, like Ton is able, like in 6 seconds, this one block, it can handle like enormous amount of transactions all the time. And it is sharding, it can handle them like in parallel and then get them together. So the amount of transactions is not a problem here.
Yeah, that is fine. Like amount of transaction is not a problem. But the problem is that suppose if I consider like I'm mostly focusing on a DeFi kind of thing. So we need to do is like a 2 to 3 transactions, right? The price will vary in the fraction of seconds. Then it will affect the orders, right? Suppose if I do the bulk order.
Okay. Yeah, so it's a fact. You cannot know the price and get back and execute it in something like this, not possible. So basically, just for those who didn't understand what just happened, what did you just say? So basically, we have contract A, and we have contract B. Sorry guys, I hope you can see. There's some.
can you make it?
They will not see that. You mean on flat?
Sorry.
Let's put something there. Okay, it's fine. So basically, the question was, so for example, this is Mark. Mark has an address. This is an address. So, Mark is asking contract A to send him some money. Just asking, send me some money. Here is the table of balances. So it says like, this address can get 50 coins, this address can get 20 coins, this address can get 10 coins. We simplify it as much as possible, right? So, basically, this contract A, would have to be able to handle a few messages. So it would be, first one would be, let's say, send me coins. Send me coins. So you would have to write a handler here. And when this guy, Mark, sends you a message, send me coins. But this contract doesn't know how much money it should send it. There's different contract that is stored. So what you would do is, handler of this message would actually send another message to contract B. Obviously, contract B would have to be able to handle it. It would have to have a code that is handling this kind of message. And it is getting the address, like this address, because I can know the sender here. Obviously, I can know the sender, so we're sending the sender address. And then I'm matching the sender address to the list. Maybe it's dictionary or something. I'm searching inside of this list. I'm searching for the address. Now I know the amount. Let's say it's 20. And same handler that handled this message is actually sending another message here. And in this message, it is address plus amount. So basically, second handler that should be on this contract is just a sender. So sender is universal. It always gets the address and amount, whatever. But this contract has to make sure that it only accepts messages from this contract, because it is a trusted contract and not anybody else from outside can send it. So basically, there's two handlers, and this sender is actually sending this amount, 20 coins to hit this. But so this is basic logic of how this particular task would be solved at this point of time from what we went through the lecture. So whatever we know, this would be a logical explanation. But good question is, what if the price changes here? I'm trying to think. Oh, it went off again? Oh, sorry. All right. That's a good question, but I'm not sure how to answer it quickly, because what happens if the price changes? What would be the problem?
So like consider the worst scenario here. So consider worst scenario. That means suppose if I'm executing it, if I have a Dex application on top of town, so where I just wanted to transfer 100 BTC to, I wanted to convert 100 BTC to some XUSDC. So
Okay.
if I go this way, like there is a fraction of change in the price that will give you the more impact in my USDT value, right?
Mm-hmm. Yes.
Is it possible to implement some sort of a listener?
No.
I like here one more thing, like I'm not sure like how the context works in the current day. So why can't we use B to directly send the amount to the mark? So
Yeah,
why we
of course. That's another way. You could actually, but like this is not a real business case, right? We're just imagining, playing around how it could work. So you could implement this sender just here.
And here, like,
But-
what about the acknowledgement here? Suppose if I send the money from A to B, so can I get the acknowledgement in A?
You would have to send a message as well.
Yeah, like a get method acknowledgement, like
yeah.
after sending.
Not a get method. What do you mean by acknowledgement?
Acknowledgement, suppose if I transfer some tokens to particular address, I will get a transaction as kind of thing, right? So whether the transaction is confirmed or maybe it failed, some kind of acknowledgement.
No, like if you, there's another important thing before we get to this point is who stores the money? If this guy is storing the money and he doesn't know the prices,
Okay.
then we could not do that because he has to send money. And here with this message, we don't know how much money to send there, you know? But like, if this guy stores the money, why do we even need this contract?
Yeah, true.
So it's like, as you can see, it's not like right now we made up a case and we cannot judge about the efficiency of tone based on this, but I also like that we made up this case because this is educating us. We can understand the concept, and later on we will talk about more sophisticated cases. And I'm curious about the acknowledgements part still, because you kind of want this contract to be aware that this transaction was sent. Is it what I mean?
Yeah, so like if we consider the Ethereum side of things, suppose if I call one other contract that are invested in this ecosystem, like one other contract, so we'll get to know about what is the response that we have. Like, is it the
There's no
other
response.
one?
It's always one way.
Okay, in the tone.
Yeah, in tone.
In tone. Okay.
Yeah, in tone, it's not response. It's always a message that comes to you. You don't care how it was triggered. So, for example, you are sending here you send a message. It basically means how much money can I send to Mark, yeah? And once you send this message, you don't care about it. It might be that this contract ran out of balance and it just cannot send an answer back. Like, it's not answer, it's just, it cannot send a transaction that would be actually a logical finish of this loop, you know? And this means that Mark will never get money because it will not be triggered. So, this is the model how tone works. We cannot say how, like in this particular case, Mark not getting money is bad for me. But we cannot say that it's wrong for tone, right? Because this is all made for sake of scalability, and this works extremely scalable, especially with this with these work chains. Like it can be run on the same network under extreme loads. Yeah. So this is like we, in a way, we simplify things in tone. But in a way, we make it more complicated if you come from Ethereum, because in Ethereum you could do that, right? You could easily talk to the contract, and then you would, like, the final state would actually end up in the block. And here, only this transaction could be in one block, and this transaction could be in another block. So how do you, like, you cannot expect it to get an answer because it's different blocks even, like this changes the state of this contract, this changes the state of this contract. So it's like, but this is a good exercise. If someone has ideas like that, we could easily play around it.
In this use case, the loop is not closed.
Yeah, thanks. But in this use case, if the loop is not closed, and no, I understand that it's a one-way communication, right? Everything is an instruction. It's a message.
Yeah.
So you can go one way or the other.
Yeah.
So now the contract has sent a message saying send 10 ton to Mark, but then it doesn't know whether it's sent or not. It could have run out of balance. But then how does the initiator know that it has or has not been sent to Mark because the instruction has gone out? Now how does the initiator tell Mark that, hey, you received the money or not? Does it have an indexer where it can kind of go through? Is there an indexer on the blockchain that it can search through and with the block ID or something like that?
Yeah, just 1 second. Guys, let's try not to be too loud. If you want to talk, it's okay, but it's just a bit hard to understand if someone's talking. Thank you. So, the question was, how this guy will know, like the initiator, because it can be that the initiator is different entity, right? So this is initiator. So initiator is saying like, send Mark certain amount of coins. So it goes here, looks how much coins, it goes back, and actually sends or not sends, right?
Yeah, but the going back is again not in our control, right? Because
No, it's not under control.
Exactly,
We don't
yeah.
know. And your question is how B can make sure that money were actually sent to A.
yeah, just how do we ensure that there's integrity at B to make sure that his request has been successful or failure?
There is no way to do this on chain.
Okay.
Only thing that he can be sure about is about this transaction. So this triggered transaction, he could see if it's failed or not. That's the only thing we can see on chain. But this is for you, for developers, that when you build apps, you have to do two things. One thing is you have to provide the interaction between the wallet, between your app and the contract. And second thing is your dApp is actually watching the blockchain. It's like constantly watching the blockchain and looking for, like in this case, your app would have to watch this address. Did he get money? Did he get money?
Yes.
Did he get money? It would be like a constant repeat. You would watch it, and once he got money, you as an app developer, you would show the B that yeah, A got money. So,
Okay.
and all this time it would basically be just a spinner like, yeah, we're waiting for transaction. But you could also watch this address because every entity has the address. So
Yes.
you would actually would want to watch this address because you would want to see the failed transaction. Because if you see the failed transaction, you could show your user like, yo, your transaction failed. It failed somewhere else. It failed on the contract B, you know. But the user shouldn't have to go and check where it failed, you know.
Got it. So basically, it's up to the developer to build in the
Yeah.
integrity aspect of
Yes,
it.
yes,
But
that's
the
a good one.
architecture of Tron itself is that it sends a one-way messages
Yes.
and at a highly reliable speeds and scale.
Exactly.
Got it.
I wouldn't say it better. It's up to developer. Who's developer here? Who's developers? It's up to developer to provide the integrity part of this
Yeah.
whole process. So
Right.
this is important concept because when you come to Tone and start a program, you would expect like certain level of guarantees from the blockchain, but you get them on the different levels. But there's a lot of concepts that you have to keep in your head by yourself.
Got it. Yeah.
And my personal opinion, it gives a lot of control to the web developer, a lot of control, and we end up with a better web apps with the same security level of blockchain. Not security, the integrity, not integrity, the trustfulness of the blockchain. Yeah. Nice.
We can look at every use case in the program.
Yeah. Awesome.
So here, in the use case that he just mentioned,
Yeah.
so we'll need the application to look for the current price, right?
Yeah.
And then trigger that. Like you cannot read that current price in his use case. You cannot read it from a different contract. You'll have to check for the price from an external application, right from your app.
Well, what you could do, like same use case on the same web, you would ask the price here, and you would actually ask this contract to send this amount of money. But could you trust that? Because any hacker could change the number, and basically your contract would just give away. It would be an airdrop, just give away money. Because this is why we need the contract in that, because we can check on chain. This contract before sending money, it can actually go back, like go here and then go back. Not go back, but would handle the answer after some time maybe, in order to send this money. So you could take this part on web, but it wouldn't be the trusted.
But put another way, you cannot read the state of a contract from a different contract.
Yes, absolutely possible. That's exactly like, you can say it in different ways, but what I said was, you cannot run getter method of another contract, but you said it in a more academic way, which is cool. Like you cannot read a state of another contract from one contract. What you could do is you could handle a message from another contract. So, and this is, I'm not here to say that it's better than Cosmos or Ethereum. I'm just here to explain how it works, you know? So, we could have, if I had a few more guys from Tone, we could have a Q&A kind of session where we could actually argue like or talk about what is better, but I don't think I have enough experience and general knowledge to prove you that this is better than Cosmos. I see how cool it is for mass adoption. I see how cool it is for 200-300 millions of users. I can imagine that this network working like this is not going to fall down. But I don't want to claim that it is better than Cosmos because of this, and that. This is basically just a different concept. But I very much like what we do because who found it useful? Who understood it a little bit more? What is going on? Me too. Okay. Can you press the mic?
Too much. So I understood like how the flow is go. So like here we have a multiple handlers, right? The multiple handlers communication. So here who will pay the gas fees? Like, so can you tell me like who will pay the gas fees and like how the gas fee works here? In this example.
It's a good one. In Ton, you could configure it by yourself. So you could make it like this. So, for example, Mark is triggering this message, and for example, in our case, this is obviously a money holder, right? Because we need 2 contracts, so this guy has all the money. So you could build your app in a way that Mark is sending a transaction, and this guy pays for this transaction. And then this guy could send a transaction that it pays for. So this guy would pay for this transaction and also send some money for this guy. So this guy would pay for this. Oh, no. You could even do that. This guy pays for this transaction and then he also pays for this transaction. You could do that. All the payments are made by this one. So it's configurable because there is a number of modes that you can send the message with. There is even mode that you say send all the money, like all the money. It means that contract will stay empty. So there is a number of ways to configure this. You can find this in documentation, but good luck with that because there's a lot of concepts that you need to understand there, and I will talk about later how to make sure that you have someone to talk with about this. Because yeah.
Sorry, last question. When you send the message out,
when the message is sent out from initiator or any contract, what is the one thing that it returns? Is it the block ID? Is it the transaction ID? Anything about the message?
So when the message goes here?
Here. And when the message
What it returns or?
No. Anything. I think that's your question about acknowledgement, right? Because when the message is initiated, so I know that it's one way, so the message goes out and then it doesn't care about it. But how do we know that the message itself has gone out?
Oh, okay. That's a good one. Let's answer this question for the case when both have money and then there is no case that they can run out of money. So
but that's okay because if we deep down into it, that's a business application because we're looking at if they have money or not. But how do we know that we have triggered a message and the message has actually gone out and the message sending itself hasn't failed?
So there is a concept of bounce.
Okay.
A message can be bounced.
Okay.
So for example, if this, I'm not very good with explaining bouncing, but you should know that it's possible for the message to be bounced. So for example, if this contract, let's say, doesn't have enough money to process this message, or this this contract explicitly bounces message back, then it would come back. And you would have to write a handler for bounced messages, for those messages that you actually sent and they get bounced. But the thing is, the answer to your question is, if there was no bounce, we suppose it was successful. So basically, you hope for the best, but you prepare for the worst. So you prepare to handle the bounce, but if it didn't happen, it means that everything went well. So I guess this answers the question.
Yeah, that answers the question. But when I send the message out, is there a message ID that's generated saying this message has been sent out?
No.
Nothing.
We don't know. Here we don't know. We only bounce will be the message that something happened.
So if we how long should we wait? So is there a duration bounce for bounce?
No. You don't wait for nothing. It's like when I mean bounce, it means that you have a handler.
At the handler,
So
yeah.
bounce will be also a message. It's not like you send
Oh,
and you
it's also
wait
a
for
message.
bounce. It's
Yeah,
also
yeah.
a message. So you just write a handler for bounce messages.
Okay.
And when bounce message comes, you don't know it comes because of you send this one or because you send another one. You just have to handle the bounce properly. So that's the thing.
Yeah, maybe what we can do is when the message is sent out, you generate your own and then log in.
Oh, there is a
We have the handler there, yes.
off-chain. There is a cool thing. It's a sequence number. It's amount of transactions.
Yeah.
So it's a cool thing to understand how many if the transaction already happened. So
Yeah.
but it's for off-chain for web mode. It might be useful for you.
No, I think I understand.
Okay, we can actually get back to this kind of, because I love this exercise too. I love to interact with you guys. So we kind of have the right wing is kind of winning this whole conversation here. So many good questions. You're like, should we like turn it like this side? Yeah, let's do some applause. Yeah, so the right wing is doing great. Yeah, I really I encourage the front wing and the left one. Guys, get into it. Yeah, let's do it. So, I think maybe let's temporarily remove it from here because you wouldn't see the, or do you see the screen?
Yeah, I can see.
Is it fine? Okay. Let me see what we get next. Yeah. Okay. Let me close because now it's also a cool part. I love this. This is my favorite part. Okay, I'm lying. My favorite part was save money tomorrow. This is my favorite part. So, sell is a very important concept. Wait. So, basically, I used to say cells. So we know there's TVM, we know there's cells, and I once heard a cool phrase. It's called. Not phrase, it's a title, memory layout. So there is a memory layout in Ton, and I think if you read white paper, you can search for registers. So there is a number of registers like C4, C7, something. So this is all a layout of memory, but on the lower level, the whole memory of TVM of a contract. It consists of cells. So we need to understand that cell is, so everything in Tron consists of cells. Whenever you interact with data, whenever TVM, even code, is stored inside of cell. So cell has a fixed size, it has like you can see the size is 1023 bits of data, not bytes. And what is much more important, because cell is small, right? And if we have a lot of cells, how do we connect them? References. And this is a cool thing. Every cell can have up to 4 references to other cells. And with this feature, we end up with something like this. So basically, I think I'll just jump through it. Put this one down. So, basically, this one starts with one cell. A lot of times you will get the cell as a starting point to interact with your memory. So basically, you can write something into this cell, something that fits the size, and then at the end you could write 4 references to 4 other cells. And in those cells, you would also write something or put references. So you would end up with an infinite tree of cells. But it all starts with one cell. And tomorrow when we'll program a smart contract, we would actually see that when you access the storage of the contract, you get single cell. You can have infinite amount of data in there, but first you get one cell. And you as an engineer, as a developer of your contract, you need to architect the structure of this data. So it can be like immediately like 4 references. Inside of these references, there could be another 4 references, but you need to know it because your code is going to read from it and your code is going to write into it. So this is a very important thing that you need to be aware of when start programming the contracts. And another, so maybe cell is the coolest type, but it's not a, it is a type, but anyways. So integer, it's also stored in cells. So, but integers are like 257-bit signed integers. So cell is TVM cells. It's a memory, it's stack-based TVMs. And slice. Slice is cool because slice is always part of a cell. So basically, imagine you have a cell, like we talked, like 1020 something bits, right? So when you have a cell, it is kind of like packaged. You don't read it yet. So when you need to start reading from it, you actually unpack it. I mean, this is like a conceptual. You start reading it. When you say, I want to read from this cell, and it returns you slice, because slice is a pointer. Slice is a pointer in the cell. So cell, imagine cell as like horizontal. Oh, okay, why do it? So slice is a certain pointer inside of the cell that says that from now on, I'm reading this amount of something. So basically, slice is a slice of a cell. Also, a good concept to understand. Oh wait, we didn't finish with builder, because builders. So these cells, you need to build them. So basically, you run the create cell. Then you start saving data into the cell. You're architecting your own data structure. And then you actually end cell. So builder actually finishes the cell and is ready to put it into memory. And tuple is an order collection. We don't go into that too much, but here I promised to talk about messages. This is probably second most important concept to understand after cells. Yeah.
In the Dawn way, every time if you want to change any data, we have to create a new cell. And because we cannot change the existing cell, so we need to create a new cell. Can we retrieve data from the older cells like?
Impossible. It's destroyed. Cell is an immutable type. Thanks for this question because
you mentioned it is immutable.
Yeah.
Will it be destroyed or will have something?
It will be destroyed.
If I want to read older data, then we have to build indexer for that or?
Let me tell you some example of the life cycle of a cell, and I hope this answers your question. So, let's say our contract we started, and we read data from the cell. Maybe it's multiple cells, but you start from one cell, you read it. How do we write it back? Let's say we have to create a cell constructed in the same way because our code that reads the cell will run against this cell. So you have to create a cell, write everything back. So you always have to read everything out, and then you change something, you write everything back, and you replace the older cell with a new one. So older cell, it just doesn't exist anymore. I hope this answers.
If I have to build history of records, then I have to build indexer for that.
Can I have a microphone? Thank you. Please.
Hello. There is one scenario like I have to create a graph from the starting data till the current data.
Okay.
How I'm going to get those previous data? Do I have to build indexer for that, or can we get?
Do you mean
from the
starting to current data? What is this? Let's get the white paper.
from the initial state, from the state init part?
Okay, I'm gonna clean that. Can someone make a photo? If someone needs it, I'm cleaning, right? 1, 2, 1, 2. So here, I'm sorry guys that you don't see it, but let me come up with something. Is this better? Sorry guys. Sorry, is this better? Much better, right? So basically, let me stand like this. So this is a cell that we get first in the storage.
Yeah.
By the way, if you want to Google this, not Google, if you want to search this in white paper, the local storage of a contract is called C4 register. So you can just type C4 in the white paper, and you'll find the whole section with all kinds of registers. So the question is, your question is, there is a cell, it refers to two other cells, right?
Let's consider the scenario of counter contract. During the state init part, I have defined the current value is like number 10. Then in the next step, I have the new data is 11, then 12, then 13, then 14. I have to get all those records like 10, 11, 12, 13, all those records. How do I going to get it?
Let me clarify. So if this is your
Do we have
cell,
any indexer?
this is like you have in the beginning you have 10, right?
Yes.
So 10 is everything you have in the memory, right?
Yes.
And then something happened to the contract changed the state, and it became 11.
Yes.
And then your question is, how do I see the history of these changes?
Yes. Yes.
Inside of contract, impossible. Contract doesn't know, it only knows the current state.
Do we have any indexer for the tone?
Indexer,
Like to get all those history of
it is Explorer. So Explorer is actually the place you want to go, and you want to see how like each transaction affected the state. So
because Explorer also works on the same principle of indexer. Do we have any separate indexer for that?
yes, and I found it just last week. There is there is such a cool thing. If you want to talk about this more, I can. If anybody wants to index blockchain, I can tell you the project because there is the most famous API in Ton is Ton Center. I mean, Ton Center is like open source API. There's Ton API, but it is closed source. So the guys created an indexer. It's called Ton Indexer, obviously. And then another team forked them and made a candy out of it. Like they literally, like right now, I'm indexing the blockchain. It took me 3 days. It's running there. Like the indexer is running on my server. It took me 3 days to index 3.5 months, maybe even 4.5 months. So there is an index. You can index the whole blockchain, and what I get with this indexer is a Postgres database. So you could query the Postgres database to interact with the with the blockchain. So the good question is like, what if this is a balance? Because your balance is not stored in your storage. For jetons, yes, but for the native coin, your balance is not stored inside of the C4 storage. It's a native number. You can just run a function get balance, and it will tell you your balance. And this is a cool thing because explorers and wallets, they don't just run a method like get balance. What they do is they look at your address on blockchain and they take every transaction like there, like plus, minus, like plus, minus, whatever. And they calculate it to your balance. So basically, for the native, even for the native coin, this is how it's done. And I know that some guys are doing the same for the jetons. They're actually going through every transaction on the blockchain of this address, and they look how the balance changed. And they actually, to calculate the total, they actually just do all these plus minuses, and then they get the balance. So this is a valid concept. I think I understand what you mean, but it's not related to cells. Cells are immutable. Cells are destroyed once you brought something else back. But there are valid business cases where you would need to actually run over the. I see that left wing. Look, like left wing is now more active. Nice. So the front wing has to also connect.
So like in counter program, once we enter a digit, like it's 10, and I'll increase it by 1.
Yes.
And then it became 11 and then 12.
Yeah.
So he's just asking, is there any process like we can record all the numbers, like what we have done?
In your memory, in contract.
Yeah.
It's up to you. If you want it, you can do it. You really, like, you mentioned, you have, did you get the question? So it's like, but because I first I thought that they're asking if I can see the history of change of the data that was written in the cell. But the question is, how, if we can store inside of contract the history of changes of this value, you can do that, and you would have to. So, for example, you open it first time, it is written 10, and then you could, when you run the counter, you could read 10, increase it by 1, and write it back like 11, and then 10. So you would always have the current value as the first one. And if you run the getter method of the current value, you would always give the first one. But then again, when you get a message that is increasing the value, it would be like you record 12, then you record 11, then you record 10. But you would.
It will be going to increase the rate part.
Sorry?
It will be going to increase the costing of the.
Of course. It's going to be. So out of the box, you cannot do the thing that you asked, but it's possible to do it with contract, and yes, it will increase the cost.
But that kind of stuff should be done off-chain.
Yeah, I would
On
say.
a centralized server for the indexer part.
Sorry?
We can do on the centralized server. We can run an indexer and record all those transactions in a separate database.
Yeah, you would have to do it on the centralized way.
Yes.
But it very much depends on the business case, because there are some cases like with derivatives, with lending protocols, with others, you would go with some mathematics. So you would want some mathematical model to stay in the contract that would actually, you wouldn't have to store best. You would have to have some formula that is when you give a new value. So there is certain value and there is a formula. So your formula is taking all like value that is current, the new value, and saves it, And like you should more combine it with mathematics for the particular business case. So you wouldn't have to store everything. If this makes sense. Yeah.
So even if the cell value in the cell is changing and it's not stored before, there should be a message. Yeah, there would be a message or a transaction that stores it, right, on the blockchain, any on-chain transaction that stores it. Even though you could index it later, if someone would want to, they could index that, but there should be an on-chain transaction, right, that stores it in any case.
Yeah, of course.
Yeah, there are things, right? You could find the state change if you index the blockchain, obviously.
I'm not sure I got the question.
Maybe the proof will store.
Sorry?
Maybe the proof will be stored in the blockchain.
Yeah.
Maybe it's
The transactions would be stored, right?
Yeah.
So if you're increasing the value, if you're changing the value itself from 10 to 11,
Yeah.
the transaction would be stored in any case, right?
Yeah, and you would have to do it off-chain, like we talked with the guys. If you want to see the history of changes, you would just parse the blockchain.
Yeah, so you just index it.
Yeah, but that's true. Whew. How much time did we do? Oh, we just, it was the whole hour, guys. It was so cool. I didn't even realize the hour left. Yeah, sure.
We are talking about indexes, right? You said you're running one of your own.
Yeah.
So, do you think it's a viable solution for developers to be running an indexer instead of having something like an archive node?
There is archive nodes.
You have archive.
Yeah.
That's better for the use case of smart contracts to call an endpoint to fetch older data.
It depends on the case, very much.
Alright.
Because, for example, I'm running this one because I'm helping my friend to build a jeton holder analytics. Jeton holder analytics. So who has how much of jetons, like top wallets and stuff. And for this, I would need to parse the whole blockchain to interact with it like continuously with SQL, for example. So that's why I did it. RJ, we went. It's already 1 hour. Do we have more time, or RJ? Do we have more time, or how much time do we have?
Like 10 minutes.
Okay. Well, let me see what we have next. Oh, we didn't even finish the messages. Wait. So let's finish this one, the last for this session, and then we will continue. Oh. That's actually a good sign that we are moving slowly, because that means that we are actually absorbing the information. Because I was afraid if we. Oh, can I have one?
Yeah, that's it.
Nice. So, two kinds of messages. As I said, in Ton, everything is a contract. Cheers. As I said, in Ton, everything is a contract. And basically, messages between contracts are called internal messages because they happen inside of the blockchain. And external messages are those that I said before, those that allow us to actually interact with blockchain from outside. And I'm going to, oh, I don't need the whiteboard. Because I really want to explain you the concept of external messages. First of all, if you are not building something like a wallet, 99% of time you're going to use internal messages. So you're not going to deal with external messages a lot, but you need to understand this concept because at some point it might save you a lot of time and money in development of your contract. So here's how it works. We have a contract, and we write. There's two default handlers. As I said, you're writing your handlers, but we're going to dig in this tomorrow. But you're writing your handlers for different kinds of messages that your contract will actually witness. But there's two default handlers. This external message handler. Oh, my MacBook again. Yeah. So basically, yeah. So this is internal message handler. This is default. It's like just built in. You can kind of like, if you don't care about external message, you just don't declare this function that is actually handling. But so how external message works? It's going to be something like this: receive external. It's a function that is doing it. So first, what you do, you have a certain. So let's say this is the space for our pseudocode. You have a certain amount given to you by blockchain because external messages, they don't bring money with them because they're sent from outside. You're gonna bring money into the blockchain outside. You can just bring some data, but all the internal messages, they bring value. They wouldn't happen if they don't bring value because they would have to pay somehow for its happening, you know. So, but external. So basically, an external message, someone has to pay for it, right? And it would be always the contract that got it. But the contract has to somehow understand it cannot pay for every external message it gets because it will be like DDoS and like all the money will go up. So what is important is that you have a certain free money for gas to identify if you want to pay for this message or you don't want. So basically you would do some logic that would identify if you want. So let's say if the last number of the last bit of the address is certain, then you don't want. And I mean, simple logic. and then you run a function, I think it's accept. I just don't remember. Because I don't, as I said, because I don't program external messages a lot. So like accept message or something like this. And from now on, you are paying for all the calculations that are going to happen. So if you don't run, you usually throw some error before if your logic didn't meet the conditions. And then you don't pay. So you just spend the free gas that is given by network, and you say, no, I'm not going to pay for that thing. And if your logic is so difficult here that it's not enough for you, like it's not enough, the free gas is not enough, then the message will just fail. So this is the concept how external messages work. Does it make sense? I would really love to hear from someone there, like guys, internal versus external messages. Does it make sense? What is the difference?
If any user makes any script when it will run infinite number of times, then what happens to the gas fee? It will be run out of.
You only have limit amount. It's like 10,000 grams, I think.
In this use case, I agree with you. What happens is someone knows this and then just sends on a daily basis 10,000 requests.
Yeah.
Just pointless requests. Whatever the number of requests are to expire your gas fee, the free gas limit.
The free gas is not like, you don't have a limit of free gas for you. It's like, it's a network. It's a network airdrop. You cannot gain from it. It's like, it's just network losing it, but you wouldn't gain from it.
So does it cause congestion to the network? Let's say if someone tries to just spam these
I don't think that, no. I mean, at least I wasn't aware of the concerns like
So it
that.
requires a very, very large scale for something like that.
I wish we would hit that problem.
Yeah.
I imagine like after, so we are ready for 1 billion users. After 10 years, I'm sitting like all the guys sitting in the conference, and someone is teaching like, we're ready for 10 billion users. and we're gonna do this, and that. I'm like, oh, these days when we were getting ready for 1 billion users.
So does that external message allow bring external data to our contract? Does that handle allow us to bring external
Yes,
data?
exactly.
So let's say in that first use case that you was mentioning, can I bring in the current price from my trusted source?
Exactly. Yeah. Oracles often use that. Oracles often use that approach. And let me give you a business case. Why did I even go so deep into the external messages? Because I wanted to give you also a real life example that you're actually interacting with external messages every day if you're using the Tone wallet. Because I will show you how it works. So. So for example, this is your mobile phone. You have your non-custodial wallet on your mobile phone. You own your keys. That's what I hope every one of you does. And you are planning to send you're planning to send a transaction to Mark, of course. Send money to Mark. So this is Mark. And this is who? Tell me name. What? Side. Okay. I will send you my address. So basically, okay, let's do that. I won't send tons. Mark wants to send tons here. So keys, the keys, like the mnemonic or whatever, it's here. Like how to do it. So the keys are here. So what I'm doing here is I'm creating a transaction. I'm creating and signing a transaction that I'm sending to the backend. So this is the backend of the Tom Hub or Tom Keeper or whatever. That's why when we're talking about the wallets are pretty much centralized, because this is the single point of failure, their API. There's a very small amount of wallets that are actually interacting with the nodes like immediately, and they're quite slow, to be honest. So this is backend. So I already signed the transaction. So how do you say? This is like a letter. It's a signed transaction which says send money from Mark here with this certain amount. I signed it. It's like it's already over. If it gets to the blockchain and I lose this money, I mean, I'm sending this money. That's what I want actually. So, but this is the backend of the Tom Keeper. But as I said, wallet is a contract. So this is just an interface. The contract is not on your phone. Obviously, the contract is somewhere here. It's Mark's contract, and then there is another contract, sales contract. So I'm sending the signed transaction to the backend, and what it does, the backend of the Tom Hub or Tom Keeper is sending an external message to the contract of my wallet, and it is first like the external handler will actually verify that it was me who signed this transaction, and then it will send internal message. Here's like internal message, because now it will actually have money with it. So this is the logic how the wallets work, and this is why we need those external messages. Does it make sense? No? Yes? Nice. Yeah, I think.
Mark,
Yeah.
why do we have to make a transaction or we have to send money to make wallet active?
Sorry, I didn't understand.
Why do we have to make a transaction or send the money from a particular wallet to make it active? We just make it active.
We have to send money to a wallet to make it active. Why we have to do it?
Why do we have to send money to the wallet to make it
Money
active?
from the wallet.
Because it's a contract. Why would you need a contract without money to be on the? Because if your contract runs.
Wallet can receive money from the external sources.
Sorry.
Wallet can receive money from the external sources. Then wallet have those money. Then in those cases also it can become active.
Why we only have to first send the money to the
Money from the wallet.
From the wallet.
from wallet to make it active? Because we can also receive money in that
Yeah, I
wallet
understand.
and make it active.
Honestly speaking, I don't know. Because I was asking myself the same question. Because you know this whole topic with the early miners that now are locked. So I honestly don't know. If I will know, I will tell you on the live stream sessions. Yeah. So I think we are going to have a break. What time is it? It's 3:35. So what I guess that at 4 we are going to have, or maybe a bit, we're going to have a VC session, like venture capital money, and afterwards we will jump on it, like continue on that, okay? Because I think it's a good idea to finish this theoretical part, so tomorrow we are mostly working with code. Okay, thank you guys, you're awesome.